Hi guys, I hope you are doing well. Please make sure you have your notes out and you're ready to go through this video in class, and then you will go ahead and complete the Math Space 7.4 powers to power expressions. So we talked this week about powers, exponents, prime factors, and even negative exponents. So if you recall, when you're multiplying or dividing variables, you're going to either add or subtract their exponents. So for example, if we had something on the lines of 4x squared y over 2xy squared, this is division, but it's also a fraction. And so what you do is you simplify the fraction part, the coefficient, 4 divided by 2, which is just 2. You could also say to yourself, well, 2 goes into 2 once and 2 goes into 4 twice, and that's where you also get 2 over 1, which is just the 2 as you see in red. And then when you look at the x squared over x, this x is going to divide away one of these. So when it divides one of them away, you're left with only one on top. And the y is similar, but the difference is that with this one, you'll notice that the y on top is going to take out or divide away one of these, leaving one on the bottom. And so you're left with 2x over y as your final answer. The other way of doing this question would be to look at it in terms of how the rules of exponents. So if we have our original 4x squared y over 2xy squared, you would divide 4 divided by 2, which is 2. And then the variable x in the denominator really has an exponent of 1. So then because you're dividing variables, you subtract their exponents. So you would get x to the power of 2 minus 1, which is just 1. And then the y, you would get y to the power of, remember there's an understood 1 up here, 1 minus 2, which would give you negative 1. And then from there, that's where you would then say, oh, I'm not allowed to have a negative exponent because it's telling me I am in the wrong part of the fraction bar. And the y is the only one with a negative exponent because the x is positive exponent of 1. And so you would bring him down to the bottom, make him positive, and you would get the same answer, 2x over y, whichever way you did it. Similarly, if you are going to be multiplying, you would do something similar in that you would remember that when you're multiplying, let's say I'm multiplying 4x squared y and 2xy squared. When multiplying, you multiply the coefficients, 4 times 2, which is 8. You keep the base, so x to the 2 and 1. So if there's 2 x's here and there's 1 here, you really have 3. 2 plus 1, 3. And y, you have a 1 exponent here, and you have a y squared, which means 2 y's. So really that's 3, or 1 plus 2, which is 3. And you would get 8x cubed y cubed. So this one that we just did is multiplying variables, where when multiplying you add their exponents. What we're going to talk about today is powers to powers. So when you raise a power to a power, think about what that means. That means you might have something like 2x cubed, and that entire thing is being raised to the power of 3. So think about what that may possibly mean. So the question is, what happens when you take an exponential expression and put it to an additional exponent? So that is like the one we just thought about, 2x squared, and that whole thing is being raised to the power of 3. So what does that mean? Well, if we were to write this out the long way, what we're saying is that we have 3 sets of 2x squareds. They are all being multiplied together. And then if we were to break each one of those up into what they mean, expanded form, we would have 2 times x, but we would really have that 3 times. And if we did it the long way, you would notice that it's 2 times 2, which is 4, times 2, which is 8. So there's 3 sets of 2's. And there's 2, 4, 6, a total of 6 x's. And that 3 sets of 2's, remember 2 times 2 times 2 is actually 8. So in reality, what you're doing is when you have a power that is raised to an additional power, so here's a power because that's an exponent. Remember that a power is an expression that has an exponent. And here we have an exponential expression to another exponent. So it's like power to power. What you do here is you're repeatedly multiplying it, just like we drew it out here. When you take a power and raise it to a power, you're repeatedly multiplying repeated multiplication. So here, for example, the x squared, that's repeating x times x, and you're repeating that repeated multiplication. So you use what we call the power to power rule. And the power to power rule basically says when you have a power raised to an additional power, you multiply the exponents and you raise the coefficient to that power. So this is the keynote basically. X to the m raised to the n is really x to the m times n. So that's what we do, we multiply them. But as you notice here, when we looked at the example above here that we wrote out, in reality what happened was that we had our 2x squared, and that was raised to the power of 3. And the shortcut way of doing it is raising the coefficient to the power. That's what we're saying here, raise the coefficient to the power. So it's really 2 to the power of 3, because it's understood that if there's nothing listed there, it's automatically a 1. And 1 times 3 is 3. That's where you get 2 to the 3. And then you do x to the 2 times 3, which is 6. And then you simplify 2 cubed, which is 8, and then x 6. So instead of having to write out that whole entire 2x times 2n times x times x times 2 times x 3 times, like we did up here the long way, you can use the power to power rule, which basically says you distribute that exponent that's on the outside of the parentheses to everything on the inside, including the coefficient, which is the number. And remember that a number that's in front of a variable has an understood exponent of 1. It's understood to be there. So then if we look at this example, x squared cubed is really x squared times x squared times x squared. And each x squared is really 2 x's, so in reality it's x squared times x squared times x squared, which really is x to the 6th, because there's 6 of them altogether. So when in doubt, always write it out. It's always okay to write it out the long way if you want, but if you understand the shortcut, it's much better to do it that way. Now, remember, when you're raising a power to a power, you multiply the exponents and you raise the coefficient to the power. So if we looked at this example, what we're doing right here is we are raising 4x to the power of 3. So that means we have 3 sets of 4x's. So the long way of doing it could be you have 4x times 4x times 4x, and then you go ahead and you multiply 4 times 4, which is 16, times another 4, which is 64, and then you get x times x, which is 64x to the third. The short way would have been to just take that exponent of 3 and distribute it to the 4. So now it's 4 to the 3. And be very careful, because the biggest mistake people make is they may say 4 times 3. It's not 4 times 3. It's 4 to the power of 3, which is very different. So don't make that mistake. Keep an eye on that. And then you do x to the power of, well, there's an understood 1 there, so 3. and then you simplify it, and you get 64x to the third. So that's the really short way of doing it, just distributing that exponent. The long way of doing it would be to write it out the long way like this, which is always okay to do. Okay, let's look at this one. 3x to the third raised to the power of 2. Pay close attention to the fact that here, only the x is being raised to the 3. This is really 3 times x to the 3. So the shortcut would be take that 2 and distribute it here. So it's 3 to the power of 2. And power to power multiply. X to the 3 times 2 is 6. And the reason you multiply is because here it's telling you have 2 sets of 3 x's. So if you were to visualize that, which is absolutely fine to do, if you were to visualize that, you would say, I have 2 sets of 3x cubes. So really, I have 3 squared and x6, which is 9x6. All right, let's look at this one. With this one, it's really important to look at that negative in front, because what this is saying is it's telling me that I have the coefficient understood to be 1 in front. So this is really negative 1 m squared, all of it to the power of 5. So the shortcut way would say, well, negative 1 is being raised to the 5. So the whole negative 1 is being raised to the 5. And when you have an odd number of negatives, you're going to have a negative, because negative 1 times negative 1 5 times is going to actually give you, well, this becomes positive 1. This becomes positive 1. But when I multiply it by that extra odd number, it makes it negative. So negative 1 raised to the power of a negative is always going to be negative 1. So this part here is going to be negative 1, and then power to power multiply. M, 2 times 5 is 10. Think of it as just negative m to the 10. One way of looking at this is when you have an odd number of negatives, you're always going to have a negative. So because of the fact that this is an odd number, there's 5 is an odd number, that means that the whole thing is going to be negative. So that's where we got that answer from. All right, number 3. Again, you are taking 4 and you are raising it to the power of 2. And a, which currently is to the negative 5, power to power multiply. Negative 5 times 2 is negative 10. If I was to simplify this, I would get 16, a to the negative 10. But remember that you are not allowed to have negatives as exponents. So if your answer in the process of solving it gives you an answer with a negative exponent, you have to remember that the part that has that negative exponent, which is the a, needs to be relocated on the fraction bar and brought down if it's on top. So the 16 remains on top, and a now becomes to the power of positive 10, and now it's on the denominator. Remember, a negative exponent tells you you're a fraction. You're just in the wrong part of the fraction bar. Okay, this one looks a little bit different just because it's got capitals. But in this example, it's the same type of thing. You're taking the 3 and you're taking the m, and they're multiplied together, but each one is being raised to the power of 3. So it's 3 to the power of 3, which is not 9, it's 27, because this is 3 times 3 times 3, which is 9 times 3, 27. So don't get confused and think it's 3 times 3. It's 3 times itself 3 times. And then m, capital M, to the power of 3. That little t right there is after the fact, so he just gets rewritten. So 3 cubed is 27, right? 3 times 3 times 3. Then you get m to the 3, and the t just kind of hangs on there because of the fact that it was not being raised to the power of 3. Okay, it was not being raised, only this expression part. Okay, you guys try. So go ahead and pause the video and work on these 4. And then when you want to go over number 1, you can press play and I will continue. All right, so in this case, you are distributing the 2 because you are raising that whole thing to the power of 2. So it's 3 to the power of 2, x to the 2 times 2 because power to power multiply, and y to the 2. All right, so you get 3 squared, which is 9, x to the 4, y to the 6. Go ahead and pause it, and then come back and do the next one. So here we have x to the negative 2 raised to the power of negative 3. Same power to power rule, so power to power multiply, and you get x to the negative 2 times negative 3 gives you positive 6. And since you already have a positive exponent, you just leave it as is. Go ahead and pause it, try the next one. Okay, with this one, notice that the negative 3 is being raised to the 4. So that whole negative 3 is being raised to the power of 4. So I put it in parentheses to not mess up the negatives. And then it's x to the 2 times 4, which is 8, and y to the 3 times 4, which is 12. Negative 3 to the power of 4 is really 4 sets of negative 3, so it's negative 3 times itself 4 times. Negative 3 times negative 3 is 9. And this negative 3 and negative 3 is 9, so 9 times 9 is 81. So that gives you 81, x 8, y 12. All positive exponents, leave it as it is. Pause it, do the next one. All right, notice here that the negative is after the fact. The negative is kind of out of everything. It's saying negative of whatever that parentheses to the 4th is. Think of it, as silly as it may sound, like a lampshade. If I have a lamp, the shade itself is directly attached to the pole, and the base underneath it is just kind of extra. So think of it as that negative that's out in front is after the fact. So you've got that 4, which is raising the 2x cubed y. So the 2 gets raised to the power of 4. And there's an understood 1 there, so 1 times 4 is 4. So 2 to the 4th. Don't forget, there's a 1 understood. If there's only 1, 2, then the exponent is 1. So it's 2 to the 4, x to the 3 times 4, which is 12, and y to the 4, because there's an understood exponent of 1, and 1 times 4 is 4. So our power of power rule multiply still holds true. Don't forget to rewrite that negative. That's still there. It's all after the fact. 2 to the 4th is the same thing as 2 times 2, which is 4, times 4, which is 16. x 12, y 4 gets rewritten. And that's your final answer because the negative was after the fact. So make sure that for the next couple of minutes, what you are working on is your math space assignment, which is required that you complete it. It is math space 7.4. That's your formative 7.4 assignment. You also have an additional worksheet that is available in Canvas. If you go to Monday in the calendar, it is kind of like your Sunday post. On that, you can go to Thursday and you will see in blue worksheet 7.4 powers of monomials. It's not required for you to complete this worksheet, but you will work on some of these questions with Miss Moss for extra practice. And you're welcome to work on those as well right now before beginning math space. The math space is due tomorrow, Friday, March 22nd. It must be completed by then in order for you to get credit and to make sure that you are eligible to reassess. That is the formative assignment. Tomorrow, Friday, we will review. I hope you guys are having a good day, and I will see you guys after next week.